Those brief glimpses revealed one more surprise. Venus is geologically active, or at least was in the relatively recent past. The surface is younger than Earth's, somewhere between 300 million and 600 million years old, suggesting a global resurfacing event where volcanic activity covered the entire planet with fresh lava. Unlike Earth, where plate tectonics continuously recycles the crust in a steady, ongoing process, Venus appears to resurface catastrophically. Volcanic activity builds up pressure beneath a stagnant crust until the entire planet experiences simultaneous eruptions, flooding the surface with lava and starting the cycle over again. If this theory is correct, Venus might be overdue for another global resurfacing event. Venus spins backward, has days longer than years, maintains surface temperatures that can melt metal, lacks any moon, and might periodically flood its entire surface with lava. Earth's twin? Perhaps in size? But in character, Venus is utterly alien, a reminder that small differences in distance from the Sun and in planetary history can create radically different worlds. Now we move outward again, past Earth for the moment, to the fourth planet from the Sun, to the red world that has captured human imagination for centuries, to the planet where we have landed more spacecraft than anywhere else beyond Earth, to Mars, the world that was once wet and might harbor evidence of ancient life. The sun's hidden song. The morning sun rises gently over the horizon, painting the eastern sky in shades of pink and gold. You step outside and feel its warmth on your skin, see its light illuminating the world around you. It seems peaceful, steady, unchanging. The most reliable presence in the sky, rising and setting with perfect regularity, a constant in an uncertain world. But this perception is an illusion created by distance and the limitations of human senses. The sun you see is not peaceful, it is not steady, it is not unchanging. It is a churning sphere of superheated plasma, where nuclear fusion releases the energy of millions of atomic bombs every second, where magnetic fields twist and snap with unimaginable violence, where temperatures reach 27 million degrees Fahrenheit at the core. And most surprisingly of all, it sings. Not in any way you could hear with your ears, of course. Sound cannot travel through the vacuum of space. But the sun vibrates. It oscillates. It resonates with millions of different frequencies simultaneously, creating a symphony that scientists have detected, measured, and even translated into audible sound waves that human ears can perceive. This phenomenon is called helioseismology, discovered in the 1960s when scientists noticed something unexpected. The surface of the sun was moving, not just the obvious churning of solar storms or the rotation of the sphere, but subtle ripples, wave-like patterns that suggested the entire sun was ringing, like an enormous bell struck by an invisible hammer. These waves are created deep inside the sun. The core, where hydrogen fuses into helium, generates heat that wants to rise. Cooler plasma at the surface wants to sink. This creates massive convection currents, rivers of plasma flowing through the sun's interior. These flows generate pressure waves, sound waves essentially, that bounce and reflect through the different layers of the sun's structure. Each wave has its own frequency. Some complete a cycle in just a few minutes. Others take hours. The sun vibrates with millions of these frequencies at once, each one revealing information about a different depth, a different layer, a different aspect of the solar interior. When scientists translate these oscillations into sound frequencies humans can hear, the result is eerie and beautiful. A deep resonating hum, like the tone of a massive pipe organ, punctuated by higher frequencies, complex harmonics that create something approaching music. The sun sings a complex song to the universe, and we have learned to listen. But this is more than just an interesting curiosity. By studying these vibrations, scientists can see inside the sun. They can map its interior structure layer by layer. They can measure how fast different parts rotate, discovering that the core spins faster than the surface. They can detect changes in the sun's internal dynamics, spotting potential problems before they affect Earth. The sun is approximately 4.6 billion years old, formed from the same cloud of gas and dust that created all the planets. But it has not always been as bright as it is today. When the sun first ignited, When nuclear fusion began in its core, it was about 30% dimmer than it appears now. Over billions of years, as the fusion process has continued, the sun has gradually grown brighter. This creates a puzzle scientists call the faint young sun paradox. If the sun was 30% dimmer 4 billion years ago, Earth should have been frozen solid. The temperatures should have been far too cold for liquid water to exist. Yet, geological evidence clearly shows that Earth had oceans 4 billion years ago, that liquid water covered much of the surface, that life emerged relatively quickly once the planet cooled enough to have a stable crust. The solution involves Earth's early atmosphere, which contained much higher levels of greenhouse gases that trapped heat far more efficiently than today's atmosphere. But it also tells us something important about the sun. It is not constant. It never has been. It changes slowly by human standards, but significantly over geological time, and it will continue changing. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core. The core will contract and heat up dramatically. The outer layers will expand, swelling until the sun becomes a red giant, hundreds of times larger than it is now. Mercury will likely be engulfed. Venus will certainly be consumed. Earth might be swallowed as well, or it might survive in an orbit just beyond the sun's swollen surface, baked to a lifeless cinder. But that is 5 billion years in the future. For now, the sun remains stable in what astronomers call the main sequence phase. It will continue shining steadily for billions of years to come, providing the energy that drives Earth's weather, ocean currents, and the photosynthesis that forms the base of the food chain. Clouds form and drift across Titan's orange sky. Rain falls, not water rain, but liquid methane rain. The methane cycle on Titan is similar to the water cycle on Earth. Methane evaporates from lakes and seas, forms clouds, falls as rain, flows through river channels, and collects in low areas, forming lakes again. Titan has lakes and seas of liquid methane and ethane on its surface, the only other world besides Earth with stable liquid on its surface. The largest, Kraken Mare, is bigger than the Caspian Sea on Earth. These hydrocarbon seas would not support life, as we know it. The temperature is negative 290 degrees Fahrenheit, far too cold for biochemistry based on liquid water. But some scientists speculate that exotic life forms might use liquid methane as a solvent instead of water, creating a biology utterly different from Earth's. The Huygens probe landed on Titan in 2005, becoming the first spacecraft to land on a world in the outer solar system. It transmitted images showing a landscape eerily similar to Earth's, rounded pebbles shaped by flowing liquid, channels carved by methane rivers, a horizon obscured by haze. The chemistry is alien, but the processes are familiar. Titan experiences erosion, sedimentation, weather, and seasons. All the geological and meteorological processes that shape Earth. But with methane playing the role that water plays on our world. Saturn, with its magnificent rings, its hexagonal storm, and its Earth-like moon Titan, is a world of beauty and mystery. But our journey is not finished. Beyond Saturn lie 2 more giant planets, the ice giants Uranus and Neptune, worlds so distant that they were unknown to ancient astronomers and remained mysterious even after their discovery. Let us continue outward into the cold darkness of the outer solar system to visit these distant worlds. A journey through our cosmic backyard. Picture yourself standing in an open field on a clear, moonless night. Far from city lights, far from the glow of civilization, you look up at a sky scattered with thousands of stars, each one a distant sun, each one perhaps circled by its own family of planets. The view is breathtaking, humbling, a reminder of the vastness that surrounds us. But here is something remarkable that most people never consider. You do not need to travel to distant stars to find wonder. You do not need a spaceship capable of crossing light years or a telescope pointed at far galaxies. Some of the most astonishing, mind-bending, reality-shifting phenomena in all the cosmos exist right here, in our own solar system. The collection of worlds that orbit the same star that warms your face each morning. Tonight, we are going on a journey, not through distant space, but through our own cosmic neighborhood. We will discover facts about the planets, moons, and sun that will genuinely surprise you. Things you never learned in school, details that scientists themselves have only recently uncovered. We will explore a solar system that is stranger, more dynamic, and more wonderful than any textbook could capture. And we will do it from exactly where you are right now, comfortable and relaxed, in that gentle space between the end of the day and the beginning of sleep. Before we begin, I want to ask a small favor. If you are ready to explore the cosmos with me tonight, to discover surprising truths about our solar system that will change how you see the sky, tap that like button. It helps this video reach others who might find wonder in these evening journeys through space and science. And if you want to make this a regular part of your night, subscribe to the channel. I create videos like this several times a week, each designed to fill your mind with fascinating knowledge while helping you drift peacefully toward rest. Now, tell me in the comments where you are watching from tonight. Are you in bed in Chicago as midnight approaches? Sitting in a chair in Berlin as dawn begins to lighten the sky? Resting on a couch in Melbourne as afternoon fades? I love seeing how this community of curious minds spans the globe, connecting people across this small planet we share. Get comfortable now. Adjust your pillow. Let your shoulders drop. Let your breathing slow and deepen. Maybe turn on a fan for that gentle white noise that helps some people relax. Tonight, we travel through space, but you need not go anywhere. The solar system will come to you, one surprising discovery at a time. Our journey begins not at the distant edge of the solar system, but at its heart, with the star that gives us light and warmth and makes all life on Earth possible, with the massive ball of plasma that seems so constant, so unchanging, so simple. You have seen the sun thousands of times. You think you know it, but I promise you, within the next few minutes, you will learn something about our star that will make you see it differently forever. Let us step outside on a quiet morning, feel the sun on your face, and discover what is really happening 93 million miles away. Olympus Mons is probably extinct now. Mars's interior has cooled too much to support active volcanism. But the mountain stands as a monument to Mars's volcanic past, proof that the planet was once geologically active, that internal heat once powered processes similar to those still shaping Earth. Mars also has polar ice caps that grow and shrink with the seasons. The planet's axis is tilted like Earth's, creating seasons. During winter at each pole, carbon dioxide from the atmosphere freezes out, adding a layer of dry ice to the water ice caps. In summer, the carbon dioxide sublimes back into the atmosphere, shrinking the caps. These seasonal changes create winds as the atmosphere shifts mass from one hemisphere to the other. The winds lift dust, sometimes creating storms that can engulf the entire planet. These global dust storms can last for months, blocking sunlight and creating a planet-wide twilight. Mars rovers have had to shut down during such storms, waiting for the dust to settle before resuming operations. Beneath the surface, Mars hides another surprise. Water ice exists in vast quantities just below ground at high latitudes. The Phoenix lander discovered this ice in 2008, digging just a few inches before finding frozen water. Subsequent observations have found ice deposits across much of the planet. Some estimates suggest there is enough subsurface ice on Mars that if it all melted, it could cover the planet several feet deep. This ice is a remnant of Mars's wetter past. It is also a potential resource for future human explorers who might extract the ice, melt it, and use it for drinking water or to make rocket fuel by splitting it into hydrogen and oxygen. Mars, the red planet, the world of dust storms and giant volcanoes, of ancient rivers and vanished oceans, continues to surprise us with each new mission. It is the planet we have explored most thoroughly after Earth, the world where we have landed rovers that continue to search for signs of past life, the destination where humans might someday walk. But Mars is still a terrestrial planet, rocky and solid, similar in basic nature to Mercury, Venus, and Earth, even if different in details. Now, our journey takes us across a boundary. Past Mars lies the asteroid belt, and beyond that belt, we enter a realm of giants. The outer solar system is dominated by planets so different from the inner ones that they seem to belong to a different category entirely. Let us cross that boundary now and visit the first of the giants, the largest planet in the solar system, the world of perpetual storms and dozens of moons. Let us discover Jupiter. Venus, the backward planet. From Earth, Venus appears as the brightest object in the night sky after the moon, a brilliant point of light that outshines every star. Ancient peoples called it the morning star or evening star, not realizing they were observing the same object. It seems beautiful from a distance, shrouded in reflective clouds that make it shine with steady, unwavering light. But approach closer, and beauty becomes horror. Venus is almost exactly Earth's size, about 95% of Earth's diameter. Its mass is about 90% of Earth's. Its composition is similar, rocky and metallic, formed from the same materials in the same part of the early solar system. For these reasons, Venus is often called Earth's twin or sister planet, but any family resemblance ends with size and composition. Venus is not Earth's twin, it is Earth's nightmare. The surface temperature on Venus is about 900 degrees Fahrenheit, hot enough to melt lead, hotter even than Mercury, despite Venus being nearly twice as far from the Sun. The atmospheric pressure at the surface is 90 times greater than Earth's, equivalent to being 3,000 feet underwater. The air is almost entirely carbon dioxide, with clouds made of sulfuric acid that rain down but evaporate before reaching the ground. This is the most extreme greenhouse effect in the solar system. Venus probably once had oceans like Earth. Water likely covered much of its surface billions of years ago. But at some point, a feedback loop began. Volcanic activity released carbon dioxide into the atmosphere. The carbon dioxide trapped heat. The heat caused more water to evaporate. Water vapor itself is a greenhouse gas, so even more heat was trapped. Eventually, the oceans boiled away completely. All the water vapor was broken apart by ultraviolet light from the sun. The hydrogen escaped to space. The oxygen combined with surface rocks. What remained was an atmosphere of pure carbon dioxide that trapped heat so efficiently that the surface became hotter than an oven, hotter than a crematorium, hot enough to make metal glow. Venus is a cautionary tale about greenhouse effects gone wrong, about how a planet similar to Earth can become utterly uninhabitable through atmospheric changes. It reminds us that Earth's pleasant climate is not guaranteed, not stable, not something we can take for granted indefinitely. But Venus has surprises beyond its hellish conditions. The planet rotates backward compared to most other planets. While Earth and the other planets rotate counterclockwise when viewed from above the North Pole, Venus rotates clockwise. This retrograde rotation is highly unusual and suggests something dramatic happened in Venus's past. The most likely explanation is a massive impact. Early in the solar system's history, Venus might have been struck by a large object, perhaps a planet-sized body, with enough force to reverse its spin. Such a collision would have been catastrophic, possibly vaporizing much of Venus's surface, but it would explain the backward rotation. Even stranger is the rate of that rotation. Venus spins very slowly on its axis. A day on Venus, the time it takes to complete one rotation, lasts 243 Earth days. But a year on Venus, one complete orbit around the Sun, takes only 225 Earth days. Think about that for a moment. A day on Venus is longer than a year on Venus. The planet completes an entire orbit around the Sun faster than it completes one rotation on its axis. This creates a bizarre situation. From the surface of Venus, if you could somehow survive to observe it through the thick atmosphere, you would see the Sun rise very slowly in the west, creep across the sky over the course of months, and finally set in the east nearly 4 months later. The Sun rises in the wrong direction and takes half a Venusian year to cross the sky. Venus also lacks any moons, and no one knows why. Earth has one large moon. Mars has 2 small ones. Even tiny Mercury, though moonless like Venus, at least has an explanation. It is so close to the Sun that any moon would be unstable. But Venus is farther out, in a region where moons should be possible to retain. Perhaps Venus once had a moon that was destroyed or ejected. Perhaps it never captured one. The mystery remains unsolved. Soviet spacecraft that landed on Venus in the 1970s and 80s, before being crushed and melted by the extreme conditions, sent back the only photographs ever taken from Venus's surface. The images show a rocky landscape, flat plains covered in volcanic rock, a yellowish sky filtered through the thick atmosphere. The spacecraft survived less than 2 hours before succumbing to the heat and pressure. Not ancient, extinct volcanoes like those on Mars, active ones, erupting ones. Volcanoes that were shooting material hundreds of miles into space while Voyager watched. Io is the most volcanically active body in the solar system, more active than Earth, more active than anywhere else we have ever observed. More than 400 active volcanoes dot its surface. Some erupt continuously. The volcanic activity is so intense that Io's entire surface is renewed every million years or so, buried under fresh lava, making the surface one of the youngest in the solar system, despite Io being as old as Jupiter itself. What powers this extraordinary volcanism? The answer is tidal heating. Io orbits very close to Jupiter, deep within the giant planet's powerful gravitational field. As Io moves around Jupiter, the enormous gravitational pull squeezes and flexes the moon. Jupiter's gravity is so strong that it raises tides in Io's solid surface of more than 300 feet, far higher than any ocean tide on Earth. This constant flexing generates heat through friction, like bending a paperclip back and forth until it becomes hot. The heat is so intense that it keeps Io's interior molten. Magma rises to the surface and erupts through hundreds of vents, painting Io in shades of yellow, orange, red, and black from the sulfur and sulfur compounds in the lava. The discovery of Io's volcanism changed how scientists think about planetary heating. Before Io, we assumed that worlds needed internal radioactive decay, or residual heat from formation, to power geological activity. Io showed that tidal forces alone can keep a world geologically alive, generating enough heat to melt rock and drive continuous volcanism. This same principle applies to other moons. Europa, Jupiter's fourth largest moon, also experiences tidal heating from Jupiter's gravity, though less intensely than Io. The heating is enough to keep water liquid beneath Europa's thick ice shell. An ocean exists under that ice, probably containing twice as much water as all of Earth's oceans combined. This hidden ocean makes Europa one of the most exciting places in the solar system for the search for life. The ocean is protected from Jupiter's harsh radiation by miles of ice. Tidal heating provides energy. Chemical interactions between the ocean and the rocky core below might provide nutrients. All the ingredients for life, as we know it, might exist in Europa's dark ocean. NASA is planning missions to explore Europa more thoroughly, perhaps eventually drilling through the ice and deploying a probe to search for life in the ocean below. If life exists on Europa, it evolved completely independently of Earth life, giving us a second example of biology and answering the profound question of whether life is common or rare in the universe. Jupiter, the giant planet with its endless storm, its powerful magnetic field, its dozens of moons, and its volcanic satellite Io, is a world of superlatives and surprises. But it is just the first of the outer solar system's giants. Beyond Jupiter lies another world of wonder, perhaps the most visually stunning planet in the solar system. Let us continue outward to Saturn. The tilted world and the speeding winds. Uranus appears as a pale blue-green disk even through powerful telescopes. A quiet, almost featureless world that seems unremarkable compared to Jupiter's storms or Saturn's rings. But Uranus holds a secret immediately obvious once you know to look for it. The planet is tilted on its side. Uranus's rotation axis lies almost in the plane of its orbit rather than roughly perpendicular to it like other planets. This means Uranus's poles point almost directly at the Sun during summer and winter. Each pole experiences 42 years of continuous daylight, followed by 42 years of continuous night, the most extreme seasons in the solar system. No one knows for certain why Uranus has this bizarre tilt. The most likely explanation is a collision with an Earth-sized object early in the solar system's history that knocked Uranus onto its side. Such a collision would have been catastrophic, possibly vaporizing parts of both bodies, but it would explain the tilt that makes Uranus unique. This extreme tilt creates strange effects on Uranus's atmosphere and magnetic field. The planet's magnetic field is tilted nearly 60 degrees from its rotation axis, an offset from the planet's center, creating a lopsided magnetosphere unlike any other planet's. Scientists are still trying to understand how such an unusual magnetic field is generated. Despite being so far from the Sun, receiving 900 times less sunlight than Earth, Uranus has weather. Clouds form in its atmosphere, winds blow at hundreds of miles per hour, storms develop and dissipate. The energy for this weather comes not from the Sun, but from Uranus's interior. The planet generates its own internal heat, though less than Jupiter, Saturn, or Neptune. Uranus has rings like Saturn, though far fainter and harder to see. These rings were discovered in 1977, when Uranus passed in front of a star, and the star's light dimmed repeatedly before and after the planet itself blocked the star. Each dimming represented a ring crossing between Earth and the star. Uranus has 27 known moons, most named after characters from Shakespeare and Alexander Pope, rather than figures from classical mythology like the moons of other planets. The 5 largest, Miranda, Ariel, Umbriel, Titania, and Oberon, show signs of past geological activity with strange surface features that suggest complex histories. But Uranus, fascinating as it is surpassed in strangeness by the 8th and final planet, Neptune, the most distant of the major planets, the world discovered not by observation, but by mathematical prediction, when astronomers noticed that Uranus's orbit was being perturbed by an unknown object. Neptune is slightly smaller than Uranus, but more massive, making it denser. It appears as a deeper blue than Uranus due to slightly different atmospheric chemistry. And despite being even farther from the Sun than Uranus, despite receiving even less solar energy, Neptune is the windiest planet in the solar system. Winds on Neptune reach speeds of 1,200 miles per hour, faster than the speed of sound on Earth, faster than winds on any other planet, despite Neptune being so far from the Sun that temperatures reach negative 370 degrees Fahrenheit. This is surprising because planets usually have weather driven by solar heating. Hot air rises, cool air sinks, creating circulation that produces winds. But Neptune receives so little sunlight that solar heating cannot explain its powerful winds. Instead, the winds must be driven by heat from Neptune's interior. Neptune generates more than twice as much heat as it receives from the Sun, though scientists are not entirely sure how. The planet is too small and too old for its interior to still be hot from formation. Radioactive decay might provide some heat, but probably not enough to explain Neptune's energy output. Some scientists speculate that precipitation of diamonds deep in Neptune's atmosphere might release gravitational energy as the diamonds sink toward the planet's core. Yes, diamonds. Neptune's atmosphere contains methane. At the extreme pressures and temperatures deep in the atmosphere, methane molecules might be broken apart, with carbon atoms combining to form diamond crystals that rain down toward the planet's core. This process would release heat, potentially explaining Neptune's internal heat generation. Pluto, discovered in 1930 and reclassified as a dwarf planet in 2006, captured public imagination for decades. When New Horizons flew past Pluto in 2015, it revealed a world far more complex and active than anyone expected. Pluto has nitrogen ice glaciers that flow like glaciers on Earth, but made of frozen nitrogen instead of frozen water. It has mountains made of water ice as hard as rock at Pluto's temperatures, some rising more than 2 miles high. It has a heart-shaped region officially named Tombaugh Regio, filled with smooth nitrogen ice that appears to be geologically young, perhaps only a few million years old. How can Pluto, so far from the Sun and so small, have active geology? Scientists are still investigating, but internal radioactive decay and tidal heating from interactions with Pluto's largest moon, Charon, might provide enough energy to drive geological processes. Pluto has a thin atmosphere that freezes and falls to the surface when Pluto is farthest from the Sun in its orbit, then sublimes back into gas when Pluto approaches closer to the Sun. The atmosphere creates a blue haze layer from organic molecules created when ultraviolet light breaks apart methane. Beyond Pluto, the Kuiper Belt extends outward to about 50 astronomical units from the Sun. An astronomical unit is the distance from Earth to the Sun, about 93 million miles. The Kuiper Belt is thus billions of miles across, a vast donut-shaped region filled with icy remnants from the solar system's formation. Some of these objects occasionally get perturbed onto orbits that carry them into the inner solar system, where solar heating transforms them into comets. Short-period comets, those that orbit the Sun in less than 200 years, originate in the Kuiper Belt. Long-period comets, those with orbital periods of thousands or millions of years, come from an even more distant region. The Oort cloud. This is a vast spherical shell of icy objects surrounding the entire solar system, at distances up to a light-year from the Sun, roughly a quarter of the way to the nearest star. The Oort cloud has never been directly observed. It is too far away, its objects too small and dark. But its existence is inferred from the orbits of long-period comets, which approach from all directions rather than from the ecliptic plane where the planets orbit. The Oort cloud probably contains trillions of objects, frozen remnants of the solar system's formation, scattered to the outer reaches by gravitational interactions with the giant planets billions of years ago. Occasionally, a passing star or gravitational perturbation from the galaxy sends an Oort cloud object plunging toward the inner solar system, where it becomes a spectacular comet. Comets are often called dirty snowballs, which is reasonably accurate. They are mixtures of water ice, dust, frozen gases, and organic compounds. When a comet approaches the Sun, solar heat vaporizes surface ice, creating a glowing atmosphere called a coma and two tails stretching millions of miles into space. One tail is dust, pushed by sunlight's physical pressure. The other is ionized gas, pushed by the solar wind. The tails always point away from the Sun, regardless of the comet's direction of travel, creating the distinctive appearance that has inspired awe and fear throughout human history. Comets might have delivered much of Earth's water and organic molecules during the early solar system's bombardment period. They are time capsules, preserving pristine samples of the material from which the solar system formed 4.6 billion years ago. The spaces between planets are not empty voids. They are filled with asteroids and comets, with dust and debris, with remnants of creation and harbingers of destruction. These objects connect the planets, share their history, and remind us that the solar system is not just 8 planets, but countless objects of all sizes, each with its own story. Now, as our journey approaches its end, let us return to where we began, to Earth, to our home, to the one planet we know intimately, the one world that harbors life, the unlikely paradise that makes all our observations possible. What we do know is that once life appeared, about 4 billion years ago, shortly after Earth cooled enough to have a stable surface, it persisted. It survived global catastrophes. It adapted to changing conditions. It evolved from single cells to complex multicellular organisms, from simple animals to the vast diversity of life we see today. And eventually, improbably, it evolved consciousness. It created beings capable of wondering about their place in the universe, of building telescopes to study distant worlds, of sending spacecraft to visit other planets, of asking whether they are alone. You are the result of 4 billion years of evolution, billions of generations, countless adaptations. Your ancestors survived ice ages and asteroid impacts, volcanic eruptions, and climate changes. Every single one of your ancestors, stretching back to the first self-replicating molecule, survived long enough to reproduce. You are the product of an unbroken chain of survival spanning the entire history of life on Earth. And you are made of material older than Earth itself. The atoms in your body were forged in the cores of stars that died before the Sun was born. Those stars exploded as supernovae, scattering their material across the galaxy. That material accumulated in the cloud of gas and dust that eventually collapsed to form the solar system. You are literally made of stardust. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were created in stellar furnaces billions of years ago and delivered to Earth by the same processes that built the planets we have explored tonight. This is perhaps the most profound connection between you and the solar system. You are not separate from it, not an outside observer studying it from a distance. You are part of it, made from its material, governed by its laws, shaped by its history. The solar system is not just your environment, it is your origin, your home in the deepest sense, the cosmic neighborhood that created you and sustains you. This density reveals something about Mercury's interior. The planet has an enormous iron core, proportionally much larger than any other planet. The core makes up about 61% of Mercury's volume, In comparison, Earth's core is only 16% of our planet's volume. Why does Mercury have such an oversized core? Scientists have proposed several theories. Perhaps early in the solar system's history, Mercury was struck by another planet-sized object that blasted away much of the rocky mantle, leaving the iron core largely intact. Perhaps the intense heat from the young sun vaporized much of Mercury's outer layers. Or perhaps Mercury simply formed in a region where iron-rich material was more abundant. Whatever the cause, this huge iron core has another surprising consequence. Mercury has a magnetic field, weak but definitely present, about 1% as strong as Earth's. This is surprising because Mercury is so small that its core should have cooled and solidified long ago, and only a liquid outer core can generate a planetary magnetic field through dynamo action. The existence of Mercury's magnetic field means that part of the planet's core must still be liquid, still churning, still generating the electrical currents necessary to produce magnetism. After 4.6 billion years, Mercury's interior has not fully solidified. The planet retains some internal heat, some geological activity, however minimal. These discoveries about Mercury, from the impossible ice to the oversized core to the unexpected magnetic field, remind us that even the smallest, most inhospitable worlds can hold surprises. Planets are not simple objects that follow predictable patterns. Each one has its own history, its own quirks, its own mysteries that challenge our assumptions about how worlds should behave. Now, let us move outward from Mercury to the second planet from the Sun, to Earth's twin, to the world that is almost identical to our own in size and mass, but radically different in every other way. Let us visit the closest thing to hell that exists in the solar system. Let us explore Venus. The spaces between popular culture presents the asteroid belt as a dense field of tumbling rocks that spacecraft must carefully navigate, dodging left and right to avoid collisions as they pass through. Science fiction shows asteroid fields, where spaceships weave between closely spaced boulders, where a wrong move means certain destruction. This image is completely wrong. The asteroid belt is vast and mostly empty. The total mass of all asteroids combined is less than 5% of the Moon's mass. If you collected every asteroid and compressed them into a single object, the result would be smaller than our Moon. Hundreds of thousands of asteroids orbit in the belt, but they are spread across such enormous distances that the average spacing between them is about 600,000 miles. If you were standing on an asteroid in the belt, you would not see a sky filled with rocky debris. You might see one or two other asteroids as faint points of light, indistinguishable from stars. Most of the time, space would appear empty in every direction. Spacecraft traveling through the asteroid belt do not need to dodge rocks. They need to aim very carefully if they want to visit one. But despite being dispersed, asteroids are fascinating remnants of the solar system's formation. They are leftover building materials, planetesimals that never assembled into a planet because Jupiter's gravity stirred the region too violently for them to coalesce. The largest asteroid, Ceres, is now classified as a dwarf planet, about 590 miles in diameter. NASA's Dawn spacecraft studied Ceres from 2015 to 2018 and discovered something surprising: bright spots in some craters that turned out to be salt deposits. These salts were left behind when water erupted from Ceres' interior and evaporated. This suggests Ceres has or had liquid water beneath its surface, perhaps a subsurface ocean like Europa or Enceladus. A dwarf planet in the asteroid belt with an ocean was not something anyone predicted before Dawn's arrival. Other asteroids show equal diversity. Some are solid rock, some are metallic, made primarily of iron and nickel, probably the cores of larger bodies that were shattered by collisions. Some are loose piles of rubble, held together by weak gravity. Some have their own tiny moons. One metallic asteroid, 16 Psyche, is the target of a NASA mission launched in 2023. Psyche is thought to be almost entirely metal, about 140 miles across, the exposed core of a destroyed protoplanet. The asteroid contains enough iron, nickel, and precious metals that, if brought to Earth, it would be worth more than the entire global economy. Of course, actually bringing such an asteroid to Earth would crash commodity markets and render it essentially worthless. But The thought experiment illustrates the vast resources available in the asteroid belt for potential future mining operations. Some asteroids have orbits that cross Earth's path. These near-Earth asteroids number in the thousands, ranging from a few meters to a few miles across. They pose a small but real threat to our planet. An asteroid just 60 feet across exploded over Chelyabinsk, Russia, in 2013, injuring more than 1,000 people. The asteroid that killed the dinosaurs 66 million years ago was about 6 miles across. Scientists now actively track near-Earth asteroids, cataloging orbits and assessing potential threats. No known asteroid poses a danger in the foreseeable future, but new ones are discovered regularly, and the surveys remain incomplete. Beyond the asteroid belt, beyond the orbits of the giant planets, lies another region of debris, the Kuiper Belt. This is where we find Pluto, along with thousands of other icy objects ranging from a few miles to more than 1,000 miles across. The cosmos in your hands. Our journey through the solar system is coming to an end. We have traveled from the singing sun to the icy Oort cloud, from ancient bombardments to future collisions, from worlds of fire to worlds of ice. We have discovered facts that challenge our assumptions and inspire wonder at the diversity of worlds orbiting our star. The solar system is stranger than you learned in school. It is more dynamic, more violent, more beautiful, and more surprising than any textbook could capture in simple diagrams and basic facts. Each world has its own character, its own mysteries, its own story to tell. But more than any individual fact, more than any specific discovery, the greatest lesson of our journey is perspective. The solar system teaches us humility and significance in equal measure. Humility because Earth is not the center of creation, but one planet among 8, orbiting an ordinary star in an unremarkable part of the galaxy. We are not the purpose for which the universe was made, but one outcome among countless possibilities, beneficiaries of fortunate circumstances as much as any grand design. Significance because despite our cosmic smallness, we are here, conscious and aware, capable of understanding our place in the universe, able to send spacecraft to other worlds and detect planets orbiting distant stars. We can ask questions about the cosmos and find answers through observation and reason. We can look up at the night sky and comprehend what we see. This is a gift beyond measure, the capacity to wonder, to explore, to discover. The privilege of living in an era when humanity has developed the technology to visit other worlds, to transform distant points of light into real places with landscapes and weather and geology. As you lie here now, preparing for sleep, the solar system continues its eternal dance. Jupiter's great red spot swirls through another hour of its centuries-long storm. Io's volcanoes erupt. Europa's ocean moves with Jupiter's tides. Saturn's rings orbit in their impossibly thin disk. Titan's methane rain falls. Neptune's winds blow faster than sound. Mars rovers drive across ancient lake beds. Spacecraft orbit and observe, sending back data that takes years to analyze. Scientists study and discover, asking new questions, finding new answers, slowly expanding human understanding of our cosmic neighborhood. And Earth spins on its axis, completing another day, carrying you and everyone you have ever known through space at hundreds of thousands of miles per hour as the entire solar system orbits the galactic center on its 225 million-year journey. You are part of this motion, this dance, this cosmic clockwork. You are made of atoms from distant stars, arranged in patterns complex enough to be conscious, aware, curious. In you and every other human, the universe has developed the capacity to know itself. Rest now in that knowledge. Rest knowing that you are connected to something vast and ancient, that your existence is improbable and precious, that you live on a world that is unique in the solar system and perhaps rare in the galaxy. Rest knowing that the cosmos is stranger and more beautiful than we ever imagined, full of surprises waiting to be discovered, full of mysteries we have barely begun to explore. Rest knowing that human curiosity will continue reaching outward, that each generation will learn more than the last, that the journey of discovery never ends. The surprising facts we explored tonight, the singing sun and impossible ice, the backward rotation and endless storm, the hexagonal jet stream and diamond rain, these are not isolated curiosities. They are pieces of a larger picture, clues to understanding how planetary systems form and evolve, how worlds become habitable, how the universe works. Mercury's impossible ice. If you could stand on the surface of Mercury at noon, you would experience one of the most extreme environments in the solar system. The sun looms in the sky, appearing more than 3 times larger than it looks from Earth. The temperature soars to 800 degrees Fahrenheit, hot enough to melt lead, hot enough to make many metals flow like water. The ground beneath your feet radiates heat. The rocks glow with thermal energy. No atmosphere shields you from the sun's relentless radiation. No clouds provide shade. The surface bakes under conditions that would destroy almost any material, that would kill any form of life we know within seconds. But wait until night falls. As the sun sets and darkness comes to this airless world, the temperature plummets. Without an atmosphere to trap heat, without clouds to hold warmth close to the surface, the temperature drops faster than anywhere else in the solar system. By midnight, by the deepest part of the Mercurian night, the temperature has fallen to negative 290 degrees Fahrenheit. The swing is more than 1,000 degrees between day and night. From hot enough to melt metal to cold enough to freeze almost any substance solid, this is perhaps the most extreme temperature variation on any planet's surface in the entire solar system. Given these conditions, you would expect Mercury to be utterly dry. You would expect every molecule of water, every atom of hydrogen and oxygen, to have been driven away by the intense heat long ago. You would expect this world closest to the sun to be a parched, desiccated ball of rock, devoid of anything we might call ice. But you would be wrong. Mercury has ice, water ice. Frozen water exists on this sun-scorched world, hidden in permanently shadowed craters near the poles where sunlight never reaches. This discovery shocked scientists when it was first made in the 1990s, using radar observations from Earth. The radar detected highly reflective patches near Mercury's poles, signatures that looked exactly like ice. But how could ice survive on a planet so close to the sun? When NASA's Messenger spacecraft arrived at Mercury in 2011 and began detailed observations, it confirmed what seemed impossible. The permanently shadowed crater floors contained water ice, along with darker material that might be organic compounds, carbon-based molecules similar to those found in comets. The ice exists because of a quirk of Mercury's rotation and the geometry of its polar craters. Mercury's axis is nearly perpendicular to its orbital plane, meaning it has almost no seasons. At the poles, crater walls create permanent shadows on the crater floors. Sunlight has not touched these shadowed regions for billions of years. In these cold traps, temperatures remain below negative 280 degrees Fahrenheit constantly. Any water that finds its way into these shadows, from comet impacts or volcanic outgassing billions of years ago, freezes and stays frozen. The ice accumulates over time, building up deposits that might be many feet thick. So, here is the surprising truth. The closest planet to the sun, the world that experiences the hottest surface temperatures in the solar system, has ice. Frozen water persists just a few miles away from rocks hot enough to glow, protected by nothing more than shadows that have existed since before Earth's continents formed. But Mercury holds other surprises beyond its impossible ice. The planet is tiny, barely larger than Earth's moon, the smallest planet in the solar system since Pluto's reclassification. But Mercury is incredibly dense, the second densest planet after Earth. If you could hold a chunk of Mercury in your hand, it would feel unexpectedly heavy, much heavier than a similar-sized piece of Mars, or even Earth's moon. Jupiter's endless storm and volcanic moon. The first time humans sent a spacecraft to Jupiter, no one knew what to expect. Pioneer 10 arrived in December 1973, becoming the first probe to visit the outer solar system. What it found was a world of extremes that exceeded even the most dramatic predictions. Jupiter is not just large, it is incomprehensibly massive. It contains more than twice the mass of all other planets combined. 1,300 Earths could fit inside its volume. The planet is so large that it does not actually orbit the sun in the traditional sense. Instead, Jupiter and the sun orbit around their common center of gravity, a point that lies just above the Sun's surface. Jupiter is massive enough to pull the Sun toward it. The planet rotates incredibly fast for something so large. One complete rotation takes less than 10 hours, despite Jupiter being 88,000 miles in diameter. This rapid rotation creates winds that blow at hundreds of miles per hour, organized into bands that circle the planet at different latitudes. The clouds we see are ammonia's ice crystals floating in an atmosphere made mostly of hydrogen and helium. And then there is the Great Red Spot, a storm larger than Earth that has been raging for at least 350 years, possibly much longer. We first observed it through telescopes in the 1600s. It was there then, and it remains there now, a permanent feature that refuses to dissipate despite centuries of continuous existence. The storm rotates counterclockwise, completing one rotation about every 6 days. Wind speeds at its edge reach up to 400 miles per hour. The storm is oval-shaped, with its long axis currently measuring about 10,000 miles across, though this has varied over time. Observations show the spot has been shrinking slowly over the past century, though no one knows why or whether this trend will continue. What powers this endless storm? On Earth, hurricanes draw energy from warm ocean water and dissipate when they move over land or cooler water. But Jupiter has no solid surface, no oceans, no land to weaken storms. The Great Red Spot persists because Jupiter's deep atmosphere provides a continuous energy source, and no friction exists to slow it down. Jupiter's magnetosphere, its magnetic field, and the space it dominates is enormous. It extends millions of miles into space. If we could see it from Earth, it would appear larger in our sky than the full moon. This magnetic field is generated by electrical currents and metallic hydrogen deep inside Jupiter, where the pressure is so intense that hydrogen atoms are squeezed until they behave like a liquid metal. The magnetosphere traps charged particles, creating radiation belts more intense than anything in Earth's vicinity. These radiation belts are so powerful that they pose a danger to spacecraft. Several probes sent to Jupiter have suffered radiation damage despite heavy shielding, but perhaps Jupiter's greatest surprise was not the planet itself, but one of its moons. When Voyager 1 arrived at Jupiter in 1979, it discovered something no one had predicted. Io, the innermost of Jupiter's 4 large moons, was covered with active volcanoes. Saturn's rings and hexagonal storm. If Jupiter impresses with its sheer size and power, Saturn captivates with its beauty. The second largest planet in the solar system is surrounded by the most spectacular ring system known. A sight so striking that even through a small telescope, Saturn appears almost too perfect to be real, like an artist's creation rather than a natural object. The rings are made almost entirely of water ice, ranging from tiny grains smaller than sand to chunks the size of houses, all orbiting Saturn in a thin, flat disk. The rings extend more than 175,000 miles from Saturn's center, but they are incredibly thin. In most places, they are only about 30 feet thick. Think about that proportion. If you scaled the rings down to the size of a piece of paper, they would be thousands of times thinner than that paper. They are a vast, delicate structure, a cosmic wonder that exists in stable orbits around Saturn. How did the rings form? Scientists have debated this for decades. One theory suggests they are the remnants of a moon that ventured too close to Saturn and was torn apart by tidal forces. Another proposes they formed from material left over when Saturn itself formed. A third suggests they resulted from a collision between 2 of Saturn's moons. Recent data from the Cassini spacecraft, which orbited Saturn from 2004 until 2017, suggests something surprising. The rings might be relatively young, perhaps only a few 100 million years old, rather than as ancient as the solar system itself. This discovery shocked scientists. It means the rings we see today did not exist when dinosaurs walked on Earth. They formed relatively recently in geological terms, and they might not last much longer. The rings are gradually spiraling into Saturn's atmosphere, pulled down by electromagnetic effects and drag from the planet's outer atmosphere. In another few 100 million years, they might be gone entirely, leaving Saturn as just another featureless gas giant. Saturn itself is almost as large as Jupiter, but far less dense. Saturn is the least dense planet in the solar system, Its average density is less than water, meaning if you could find an ocean large enough, Saturn would float. This low density results from its composition, mostly hydrogen and helium in gaseous and liquid form, with only a small rocky and metallic core deep at the center. Saturn rotates quickly like Jupiter, completing one rotation in about 10.5 hours. This rapid spin creates powerful winds and storms. But Saturn has one feature unlike anything else in the solar system, a feature so strange that when scientists first observed it, they thought their instruments were malfunctioning. At Saturn's north pole, the jet stream does not flow in a circle. It forms a hexagon, a six-sided geometric shape roughly 20,000 miles across, larger than Earth, rotating with the planet. Each side of the hexagon is longer than Earth's diameter. This hexagonal pattern has persisted for decades, visible in images taken by Voyager in the 1980s and still present when Cassini arrived decades later. Scientists believe it results from the interaction between different wind speeds and the planet's rotation, similar to patterns that can be created in laboratory experiments with rotating fluids. But no other planet has anything like it. Saturn's hexagon remains unique. Beyond Saturn's rings and its hexagonal storm lies another wonder. Titan, Saturn's largest moon, is one of the most Earth-like worlds in the solar system, despite being vastly different from Earth in fundamental ways. Titan has a thick atmosphere, thicker than Earth's, made mostly of nitrogen with about 5% methane. This atmosphere is so dense that the surface pressure on Titan is about 1.5 times Earth's sea level pressure. Titan is the only moon in the solar system with a substantial atmosphere, and that atmosphere creates weather. Yet even in this stable period, the sun is far from quiet. Its surface erupts constantly with solar flares, enormous explosions that release as much energy as billions of nuclear bombs. Coronal mass ejections hurl billions of tons of plasma into space at millions of miles per hour. Sunspots, cooler regions that appear dark against the bright surface, come and go in cycles lasting about 11 years. These solar storms have real effects on Earth. When a major flare or coronal mass ejection happens to be aimed in our direction, the blast of charged particles slams into Earth's magnetic field. This creates geomagnetic storms that can damage satellites, disrupt radio communications, threaten power grids, and trigger one of nature's most beautiful displays, the aurora, the northern and southern lights. Curtains of shimmering color that dance across polar skies in shades of green, red, purple, and blue. They occur when solar particles collide with atoms in Earth's upper atmosphere, exciting them and causing them to emit light. Oxygen produces green and red. Nitrogen creates blue and purple. For thousands of years, people watched the aurora and wove them into mythology. The Vikings believed they were reflections from the shields of warrior maidens riding across the sky. The Inuit thought they were spirits of the dead playing games in the heavens. The Sami people of northern Scandinavia saw them as the energies of souls moving between worlds. Science has explained the mechanism, but the aurora remain magical. They are visible proof of the sun's influence, a reminder that we are not isolated on Earth, but connected to our star by invisible streams of particles and energy. This solar wind, the constant flow of charged particles from the sun, fills the entire solar system. It creates a bubble of solar influence called the heliosphere that extends far beyond the planets. The edge of this bubble, where the solar wind meets the interstellar medium, is called the heliopause. In 2012, Voyager 1 became the first human-made object to cross this boundary and enter interstellar space. After traveling for 35 years and covering more than 11 billion miles. But even beyond the heliopause, even in interstellar space, the Voyager spacecraft remain gravitationally bound to the sun. They still orbit our star, just at an enormous distance, because the sun's gravity extends much farther than the heliopause, out to the Oort cloud, a vast shell of icy objects that surrounds the solar system, at distances up to a light year from the sun. And the entire solar system, the sun and all its orbiting worlds, is moving through space at 450,000 miles per hour, circling the center of the Milky Way galaxy. One complete orbit takes about 225 million years. Since the solar system formed, we have completed roughly 20 orbits around the galactic center. Think about that. The last time the solar system was in this exact location in the galaxy, dinosaurs had not yet appeared. The supercontinent Pangaea was just beginning to break apart. Life existed only in the oceans and in primitive forms on land. Earth was unrecognizably different. And in another 225 million years, when we return to this spot, Earth will be different again, in ways we cannot imagine. Perhaps humans will have spread across the solar system, or beyond. Perhaps an entirely different intelligent species will have evolved. Perhaps Earth will be lifeless, its biosphere destroyed by some catastrophe we cannot predict. The Sun continues its journey, carrying its family of planets through the galaxy, singing its complex song, changing slowly but inexorably, both the source of life on Earth and an eventual threat to that life's survival. Our star is dynamic, violent, evolving, and absolutely essential to everything we know and are. But the Sun, for all its importance, is just the beginning of our journey. Now, we turn our attention to the worlds it illuminates. We will start close to the Sun, where the heat is intense and the conditions are extreme, and then slowly work our way outward through the entire solar system, discovering surprises at every stop. Let us begin with Mercury, the smallest planet, the fastest orbiter, the world of extreme temperatures and hidden ice. Earth's improbable existence. Throughout this journey, we have visited worlds of astonishing diversity. We have seen storms that rage for centuries and volcanoes that erupt continuously. We have discovered ice on the hottest planet and backward rotation on another. We have explored rings and moons, asteroids and comets, finding surprises at every turn. But perhaps the most surprising fact of all is this: Earth exists. Not just that a rocky planet formed in the inner solar system, many such planets exist. Not just that water exists on Earth's surface. Water is common throughout the solar system, frozen in ice on multiple worlds. Not even just that Earth has life, we do not yet know how common or rare life might be. The surprise is that Earth exists in exactly the configuration necessary to support complex, intelligent life for billions of years. The number of factors that had to align perfectly is staggering, and changing any one of them significantly might have made Earth uninhabitable or prevented life from evolving beyond the simplest forms. Earth needed to form at the right distance from the Sun in the habitable zone where temperatures allow liquid water. Too close and we become Venus, too far and we freeze like Mars. But distance alone is insufficient. Earth needed to be the right size, large enough to have gravity sufficient to hold an atmosphere, but not so large that we become a mini Neptune with a crushing atmosphere of hydrogen and helium, small enough that we do not become a gas giant, but large enough that our interior remains molten, generating the magnetic field that protects our atmosphere from the solar wind. Earth needed to have active plate tectonics, the constant recycling of crust that regulates atmospheric carbon dioxide over geological time. Venus and Mars lack active plate tectonics, and both have severe climate problems. Earth's plate tectonics act as a thermostat, maintaining habitability even as the Sun slowly brightens. Earth needed a large moon to stabilize its axial tilt. Without the moon's gravitational influence, Earth's tilt would vary chaotically, creating wild climate swings. Mars, with tiny moons that provide no stabilization, experiences tilt variations that cause extreme climate changes. Earth needed to be in the right part of the galaxy, far enough from the galactic center to avoid frequent supernovae and gamma-ray bursts, but not so far that the star-forming regions would lack the heavy elements necessary to build rocky planets. Earth needed Jupiter. The giant planet acts as a gravitational shield, deflecting or capturing many comets and asteroids that might otherwise bombard the inner solar system. Without Jupiter, Earth would suffer far more frequent impacts, potentially preventing complex life from ever evolving. All these factors and more had to align perfectly. The probability of any given planet meeting all these requirements seems vanishingly small. This has led some scientists to propose the rare Earth hypothesis, suggesting that while simple microbial life might be common, Earth-like planets suitable for complex life are extremely rare. But other scientists argue this is too pessimistic. Perhaps life is more adaptable than we think. Perhaps there are many paths to habitability. The discovery of thousands of exoplanets orbiting other stars is beginning to provide data, though we are still far from answering whether Earth-like worlds are common or rare in the galaxy. What we know for certain is that we are fortunate. Earth is not guaranteed. The conditions we enjoy, liquid water oceans and breathable atmosphere, temperate climate and protective magnetic field, are not the default state of rocky planets. They are the result of billions of years of geological processes, of fortunate circumstances, of being in the right place at the right time with the right characteristics. And life on Earth is even more improbable. We do not know how life began. We do not understand the chemical processes that transformed non-living molecules into the first self-replicating organisms. We do not know if life emerged once or multiple times, if it was inevitable given Earth's conditions, or a fantastically lucky accident. Neptune also has storms like Jupiter, though Neptune's storms do not last as long. When Voyager 2 arrived at Neptune in 1989, it observed a great dark spot similar to Jupiter's Great Red Spot. But when the Hubble Space Telescope observed Neptune years later, the spot had disappeared. New storms have appeared and vanished since, showing that Neptune's atmosphere is dynamic and changeable, unlike Jupiter's apparently permanent storm systems. Neptune has 14 known moons, the largest being Triton, one of the strangest moons in the solar system. Triton orbits Neptune backward, retrograde, the only large moon to do so. This almost certainly means Triton was not formed alongside Neptune, but was captured from the Kuiper Belt, the region of icy objects beyond Neptune's orbit. Triton is geologically active despite being one of the coldest objects in the solar system. Its surface temperature is negative 391 degrees Fahrenheit, the coldest measured surface temperature anywhere. Yet, Triton has geysers that spray nitrogen ice and gas thousands of feet into its thin atmosphere. Triton's retrograde orbit is slowly decaying. Tidal forces are gradually slowing Triton and pulling it closer to Neptune. In a few 100 million years, Triton will pass within Neptune's rush limit, the distance at which tidal forces will overcome the moon's own gravity and tear it apart. When this happens, Neptune will gain a spectacular ring system made from the debris of its destroyed moon, perhaps more impressive than Saturn's current rings. With Neptune, we have reached the edge of the planetary realm. Beyond Neptune lies a vast region of icy objects, the Kuiper Belt, where dwarf planets like Pluto orbit in the cold darkness. But before we journey to those distant objects, we should pause and consider what we have learned about the 8 major planets. Each world is unique. Each holds surprises that challenge our assumptions. Mercury has ice. Venus rotates backward. Mars built the solar system's largest volcano. Jupiter hosts an endless storm and a volcanic moon. Saturn wears beautiful rings and has a hexagonal jet stream. Uranus lies on its side. Neptune generates mysterious internal heat and has the solar system's fastest winds. The solar system is not a collection of similar objects following predictable patterns. It is a gallery of extremes, a showcase of diversity, a reminder that nature creates endless variations on the basic theme of worlds orbiting a star. But the planets are not the only interesting objects in the solar system. Between Mars and Jupiter lies the asteroid belt, a region often misunderstood. And beyond Neptune stretches the Kuiper Belt and the distant Oort cloud, regions filled with billions of icy objects that occasionally visit the inner solar system as comets. Let us explore these regions now, discovering what lies in the spaces between the planets. Mars and the mountain that shouldn't exist. Mars glows red in Earth's night sky, a rust-colored point of light that stands out among the white stars. Ancient peoples named it for their gods of war, associating its blood-like color with violence and conflict. For centuries, humans looked at Mars and wondered if anyone looked back. We know now that no Martians exist, at least not in the form of intelligent beings gazing at Earth through telescopes. But Mars remains fascinating precisely because it shows evidence of a more hospitable past, a time when water flowed across its surface and life might have emerged in its oceans and rivers. Today, Mars is cold and dry. The average temperature is negative 80 degrees Fahrenheit. The atmosphere is so thin, it is barely there, less than 1% of Earth's atmospheric pressure. This thin air cannot support liquid water. If you poured a glass of water on Mars's surface, It would either freeze instantly or boil away depending on the temperature, but it would not remain liquid. Yet the evidence for past water is everywhere. Dry river valleys snake across the Martian landscape, carved by flowing water billions of years ago. Ancient lake beds preserve sediments deposited when water filled depressions and then evaporated. Minerals that only form in the presence of water are scattered across the surface. Even the northern hemisphere's lowlands might have once hosted an ocean, though this remains debated. Something happened to Mars. The planet had a thicker atmosphere and warmer climate billions of years ago. Water flowed, perhaps rain fell. Maybe life emerged in those ancient oceans, microbial life that might have left fossils now buried in Martian rocks. Then Mars lost most of its atmosphere. The leading theory involves the planet's small size. Mars is only about half Earth's diameter and has about 10% of Earth's mass. Smaller planets cool faster. As Mars's interior cooled, its magnetic field shut down. Without a magnetic field to protect the atmosphere from the solar wind, particles from the sun gradually strip the Martian air away, molecule by molecule. Over millions of years, the process continues today. NASA's MOVEN spacecraft orbits Mars, measuring how much atmosphere is still being lost. The rate is slow but steady. Mars is dying by degrees, losing its air to space, becoming thinner and colder and drier year by year, though the changes are imperceptible on human timescales. But Mars holds a surprise that seems to contradict everything we know about small planets and their limitations. The largest volcano in the entire solar system is on Mars. Olympus Mons rises 13.6 miles above the surrounding plain, nearly 3 times the height of Mount Everest. Its base covers an area roughly the size of Arizona. If you stood at its edge and looked toward the center, the summit would be beyond the horizon, hidden by the curvature of Mars itself. How did a planet half Earth's size, a planet that has been geologically dead for billions of years, build a volcano larger than anything on Earth? The answer lies in what Mars lacks rather than what it has. Earth has plate tectonics. Our crust is broken into large pieces that move over the surface. When a volcanic hotspot in the mantle begins erupting, the plate motion eventually carries the volcano away from the hotspot. The volcano becomes extinct, and a new one forms over the same hotspot. This is how the Hawaiian island chain formed, a series of volcanoes created as the Pacific plate moved over a stationary hotspot. But Mars has no plate tectonics. The crust is one solid piece. When a hotspot began erupting on Mars billions of years ago, the volcano stayed directly over that hotspot. It erupted again and again in the exact same location, building up layer upon layer of solidified lava, growing taller and wider with each eruption over hundreds of millions of years. Each fact connects to others, building toward comprehensive understanding. The more we learn, the more connections we see, the more deeply we grasp how everything relates. If you enjoyed this journey through our solar system, if these surprising facts brought you wonder and peace, please like this video and subscribe to the channel. I create content like this several times each week, designed to fill your mind with fascinating knowledge while helping you relax into restful sleep. Share your thoughts in the comments. What surprised you most? What would you like to explore next? This community grows with each person who joins, and your engagement helps these videos reach others who find comfort in learning. Thank you for traveling through space with me tonight. Thank you for your curiosity, your attention, for being part of this community of people who find that knowledge can be a path to peace rather than restlessness. The solar system awaits continued exploration. Mysteries remain to be solved, discoveries wait to be made. But for now, rest. Let the planets continue their patient orbits while you sleep, safe and warm on this unlikely world we call home. The sun will rise tomorrow, as it has for billions of years. The planets will continue their dance, and you will wake to another day on Earth, this improbable paradise, this cosmic oasis, this one world we know that harbors the miracle of life and consciousness. Sleep well, dream of distant worlds and ancient impacts, of singing suns and hexagonal storms, of all the surprising truths we discovered and all those yet to be found. Good night, and may the cosmos fill your dreams with wonder.